Perfect. Thank you. So, okay, first, let's just go ahead and take a quick poll. How comfortable are you with quantitative analysis today? Very comfortable, somewhat comfortable, or just kind of getting started? And Melissa, I presume that folks know how to answer this. They need instruction.
Yes, unfortunately, my polls aren't working right now, so if you want to just throw it in the chat, we can do that.
Okay, good to know.
Sorry.
That's all right. Okay, so lots of B's going through here. I think we have 100% B's, so no one's okay. Okay,
There's a
so
few.
lots of B's, a couple of A's. So okay, so for the B's, we hope to get you to be more comfortable, and for the A's, I hope to tax your limits and boundaries of what you do know. Okay, and then we have some people just getting started. So thanks. So I got a good sense of everyone's kind of mostly in that middle ground. Um, Probably have a bell-shaped curve here with B's in the center. All right, so for those B's and A's, let's go ahead and talk about some levels of measurement. It's not an academic issue of knowing the three kind of broad levels. The, the reason to know that is that different tests use different levels of measurement. So when you're coming up with a data plan that is selecting which statistics, you have to know what level of measurement your data is at. Okay. And generally, quantitative data is in one of three buckets. Nominal is name only. It's really just, as I say here, male, female, party affiliation, Republican, Democrat, Independent, if there are any independents these days. Uh, and so it's just names and labels. Okay, there's no hierarchy to be had. Ordinal data does have labels, small, medium, large, but it also has an order. Okay. The key thing here is that the intervals are not equal. Okay. Um, I used to always say, about soft drinks, between a small and medium may be 7 ounces to 12 ounces, medium to large, 12 ounces to 16 ounces, extra large may be 48 ounces. So the key thing is that, like horse races or soda drinks, that the intervals are not equal. Okay, but they are ordered. In continuous level data, you have labels: 5 years old, 6 years old, 7 years old. There is an order, obviously, and they're equal intervals, right? So aside from a leap year, you do have 365 days in between those different years. Okay. Okay, so you need to know that it's easy enough to know name, name and order, name, order, equal spacing. Okay. Okay, so quiz. So what zip code? Your zip code is a number. Which level of measurement is it? Aha! I mean, it looks like we have the and we have the polls are up and working. Okay. All right. So we got some different answers going on here. Um, okay. And give a few more seconds for people to put it in there. Okay, so I think we have an end there. That's awesome. So most people correctly said nominal. So even though it's a number, it's just a category. It's this number goes with that county, okay, or area. This number goes with that county, okay. It's a little bit tricky because it is a number. You think it might be continuous, all right. So, but it is just a name. It happens to be a name that is assigned a number, okay. All right, that was tricky. I'll give you that. Um, okay, so right, so that's just a category, just that zip code. Okay. All right. Um, let's go to the next one here. IVs, DVs, covariates. Also mission critical to know. That is, you need to know what your outcome dependent variable is. you need to know if you have an independent variable, what that is as well. So the example, does fruit type, okay, affect energy level? Okay. All right. Or the differences on energy level, okay, by fruit type. All right. So the IV is what you can change. So as the researcher, I can say, I want to look at energy level or sugar levels or glucose or something of that sort, and I pick the fruits. Okay. So as the researcher, I'm selecting that. Okay. The outcome variable is the amount of energy or the amount of sugar, okay, that an individual has or that a fruit has. Okay. So the dependent variable is the outcome variable, and it depends upon typically the participants or the observation, which in this case might well be people or fruit or something of this sort. Covariates are simply some variable that you want to neutralize, okay? So maybe someone has different energy levels, okay? They've eaten certain fruits, they have different energy levels, but some of the folks may not have slept well, okay? Some of the folks may have slept a lot, thereby influencing the amount of energy that one would have, okay? So dependent variables or outcome variables typically depend upon, for vast majority of the time, on the individual. How fast do you run? How much energy do you have? Depends upon the person. Independent variable is typically researcher selected, and covariate is something that you want to adjust for or neutralize. Okay, so does fruit type affect energy level? What is the outcome variable here? Okay. All right. So if you put in your answers, all right. So it's either going to be fruit type, energy level, or hours of sleep. And we'll give that just another second. Melissa, I have to say, I really love these polls and quizzes. Uh, all right. Final answers from folks. There's a lot of people on the call. Don't be shy. We only have about half the people responding. So A, B, or C. Okay. And I think we'll end the poll. It's fine. So the correct answer is the outcome variable is the energy level, okay? Fruit type is the independent variable that the researcher would select. I give these folks oranges, I give these folks bananas, I give these folks apples, and then I'm assessing their energy level, okay? All right. So that would have a large impact on if you selected the inaccurate outcome variable. Um, that would right, because fruit type is a nominal level, right? Energy level would be perhaps a scale level, right? Rate your energy level. Okay, so that would affect the type of test that you're using. All right. So by the way, if you didn't get it correct, you're just starting out with this, so it takes a little bit to kind of get your brain around this, wrapped around this. Okay, so let's go ahead and log in, and and you can log in at this URL here. Okay. And Melissa has also put that into the chat if you want to just click on that. Okay. And we'll just make sure everyone get logged in. And I presume I need to get logged in myself here. By the way, while you're getting logged in, just to know that they're very common to have roadblocks. People don't know what test to use. Very common. They don't know how to run it. Okay, and they don't know what the output really indicates. I think the purpose of Intellectus was to overcome those three roadblocks. Okay. All right. Well, we'll come back to this after. Okay. So let's go ahead and get logged in. Melissa, can you assess how many folks actually get logged in?
Not in real time through that, and other people log in through their own
I
links,
see.
but this is the webinar link.
Got it. Okay. So listen, I want to go back and just review those kind of three roadblocks. Okay, um, so what test do I use? How do I conduct analyses? And then what does it mean? So I just want to briefly make that a little bit larger. Briefly show you the decision tree. And the decision tree can really help you kind of boil down what kind of analysis. Okay. So if you want to predict an outcome, okay, all right, and you know that level of measurement, you'll be conducting a linear regression. So you can play around with this, but it's just kind of a user-friendly way. Once you know levels of measurement, and once you know mostly independent and dependent variable, you can play around with this. You can't break it, so just mess around with that, okay? Okay, so that decision tree is for lay people. Once you have know what kind of test you have, let's load this up. So this individual had rather long variable names. That's not helpful for tables, by the way. Um, so once you have data inputted, which I'll show you in just a moment, you can conduct descriptive statistics. Here you can see we want descriptives on gender or race, and you'll see the frequency in percents here, okay? And inside of an APA table with a little write-up, okay? Paired t-test, which is assessing differences on pre to post risk scores, okay, and independent t-tests. So different tests to be had. The key thing is that it's easy to conduct tests by selecting paired t-tests, selecting the variables, okay, like pre or post. Pardon me, and then hitting calculate. Um, one key about these tests is that the assumptions are built in for a particular test or for every test that has assumptions. You have assumptions built in, and those assumptions are evaluated in stating whether that assumption was met or not met. Okay, so let's go ahead and get to uploading data for those that are following along here. So you can go to projects and you can go to choose an example data set. And I think there's one on master class here. And let me see if it's under discipline. Let me see here. No, so it's probably under here. Okay, so if you select under name and then sort that by alphanumeric, you can go down to master class and hit select. Okay. And this is being all recorded, by the way, and everyone will have an option to look at this video. So once you select the data, you go to create project. By the way, we have a whole 80 courses that go with this thing around different tests, and these data sets are curated for those courses, be it in healthcare or education or by test. Okay, so here I just have a simple data set of age groups, movies, fruit, hours slept, and GPA. So um, once you have this data in, and you can change these levels of measurement as well, okay, by clicking that box. Data management is on the left. You can scroll over to see, okay, what that function does. We have different plots to be had. Okay, I won't go there right this second. Oh, maybe I will. If I want to see GPA by age group. By the way, these icons are getting to those three levels of measurement I talked about earlier. So you can see that scale for a ruler. The Venn diagram is nominal, and then the kind of the bar graph is ordinal. Select your variables, select the grouping variable if you have one. Should also note on every single one of the data management functions, every one of the plots, and every one of the analyses, you have a video tutorial. No more Googling around. You can kind of just see a 2-minute video about how to do that plot or analysis. So here we can kind of see the age groups over to the right. And then you can kind of scroll over to say, hey, gosh, it seemed like there was a large difference um, uh, of GPAs, okay? And then how they changed over time from pre to post, okay? Okay. And there's different options here for labeling and so forth. Okay. Under the analyses, we do really have probably 80 analyses and lots of permutations of these things. But descriptives through correlations, through t-tests, and so forth. We even have more advanced models, those that were very comfortable. You're not going to find an easier tool to run SEM or mediation moderations. So first thing everyone should do, the best practice is absolutely run descriptives on the data and the variables of interest. So let's just say I want age group, okay, sleep, GPA, okay, pre to post. Note that this descriptives accepts all 3 levels of measurement, okay? So we kind of made it kind of foolproof where you don't necessarily, you'll have to have the right level of measurement to conduct a particular analysis. At the moment, I want to look at those 4 variables. Hit calculate. And you can see for the age groups, the frequency and percent. By the way, nice scroll overs there and a little write up about that. For the scale variables, interval ratio, we have means and standard deviations, min maxes. You can edit this, and then a little write up in here. You can edit this, by the way, by going to options and saying, you know what, I want skewness and kurtosis. Okay, can save that, recalculate that, and then it will recreate that APA table on the fly. Okay, and have that there sitting for you. These numbers are perfect. So this is all driven by the R programs. So just to know that this is not hallucinated whatsoever. Okay, so to know that. Okay. If we want to run a t-test, let's imagine we want to now compare pre-test to post-test. Okay. We can go to the analysis, go to paired t-test, and put in I want to compare GPA pre to GPA post. Notice that those are scale variables. Notice the video is there. There's additional options to be had, which can be enabled and disabled. So primarily I'm caring about pre to post, okay? And just hit calculate. When I add it to the analysis, you can see the, hey gosh, so a simple write-up, right? Pair t-test, examine whether there was differences from pre to post. It is assessing, well, it's identifying that there's an assumption, happens to be abnormality. The Shapiro-Wilk test is the test that assesses normality. And when you read in articles, at least you're starting to familiarize yourself with some of these tests and have heard the word before, right? I don't expect everyone to be a statistician, but we should have some familiarity with these different names and tests. As it turns out, when that assumption is significant, okay, okay, that means that assumption is violated. So we have to interpret with caution. The results, okay, we can see the write-up of the results right over here. Okay, so the t-test was significant. Okay. So you can see that it was significant. This is one way to report it for those using null and alternative hypotheses. Okay, you would reject the null. Okay, the null says there was no difference pre to post. We did find a difference pre to post, so we're going to reject that null that nothing happened. The language gets a bit confusing, so apologies for that. So basically, once we know that that is significant, we can just really go down to the bottom and say, hey, gosh, at post test, they had higher scores on average than at pre-test, and a little plot here. Okay. Also, to address that assumption violation, that is this normality, we have enabled it's called a non-parametric test or test without the assumption to look at pre to post using ranks. You can see that that was also significant, which is just kind of validating what we found up in the t-test, that there were significant differences there. Okay. And then you have nice scroll overs here for, okay, for different plots, okay? And this should be fully scrolled over here. Okay. All righty. So, Melissa, should I go to, well, let me just go to questions here. If there's any questions, you could put into the Q&A or into the chat. I don't think I want to do that. Let me just, if I could find this. Let me just do this. Just download data and have a data set sitting here.
And we have, it looks like some people shared projects too.
Oh, good. All right, I'll get to that. Let's just do two things really quickly. One is, you know, take it from me, anybody who's doing data analysis, the data clean is the problem, okay? So we have a data cleaning wizard under projects. I'm going to upload data file, okay? Go to CSV. I think I should have that sitting here. So once you have the upload, and I've just uploaded this data file, okay, which is the masterclass data file. Once you have that, it will bring you through. If you upload from Qualtrics or SurveyMonkey, it will have different levels of headers. You can get rid of headers, okay? You can edit variable names, particularly if you have a very long name. They don't make for good tables and figures, so this is an opportunity to change your variable names. If you had misspellings, sometimes for gender, for some reason, you could have male with a capital M, male with a small m. It will help you clean that up. If there's Likert type items, you can select the point scale it's on, and it will walk you through creating a subscale. And then you can add a variable ID, just so you know if there's a outlier, okay, you would know, oh gosh, participant number 8 was the outlier. Okay. So you can identify that. So it's worth having an ID in there. Okay. Okay. See if I can get out of here. Okay, so that's data cleaning wizard is in there. The other thing that I want to show, and hopefully I can get to it, is let me see here. MBI, I think this will get me here. This is a data set of Matchlock's burnout scale. And I do have so once you have your data, okay, your analyses, okay, you can go to discussion draft and generate a discussion. So what this is going to do is contextualize your findings and go out into the literature and look to see how your results really confirm or not the literature that's out there. So you would enter the variable, excuse me, the draft name, add research questions, purpose and research questions here, pardon me, research problem, purpose of the study, research questions. Here you want to just validate that the name of the construct is fully described here. So you can see EE does stand for emotional exhaustion via the Matchlock burnout scale. So just make sure that that's all cool and then go forward. I think I have a copy of that here. So this would be an example of a discussion chapter, which really has an interpretation of the findings, okay? And then theoretical and practical implications of your findings, limitations, okay? And conclusions and recommendations. It does take a minute, but just know that that's a cool way to really kind of have a draft of your results and discuss, well, of your discussion, draft the results, download here, draft of your discussion, download here. Okay. And for those faculty that are really wondering, hey, you know what? What is the provenance of this? And do my students really understand this? We have a thing called reflections or guided reflections. And in guided reflections, it's really walking the student through the different aspects of this AI generation, like does the summary accurately reflect the results of each research question or hypothesis? Okay. So they would enter in their answer here, okay, and then go to the next one. So once you have, we'll just have AAA here. Well, can I do better than that? Probably. So I'll say yes. The research questions were fully evaluated with assumptions. Apologies for my typing. Okay. And then you would go through that for each and every aspect. Interpretation of the findings, okay? Prior research, unexpected results, reasoning, theoretical implications. So each piece of this AI is now being vetted with your understanding, okay? And so forth. Then when you download that draft, you not only have it's on the other side. You not only have the discussion draft, okay? And by the way, you should edit the best practice here to me, 2 screens. Read it, think about it, and then write it on the other side, okay, in the other screen. So you want to just make sure every sentence is edited. So for the faculty out there, and it comes with references. So for the faculty out there, you now have an audit trail of where students are with respect to the different aspects of the really results and discussion, okay? And we have this in the Lit Review app. We have a methodology app coming out in the qualitative. So these guided reflections, and Melissa, we should really brand that with a nice little brain. Okay, that'd be great. So the guided reflections, and really you have a sense of where the student is. So if the student is really blanking on some of these things, that's an opportunity. It's a learning opportunity to help them through that before they get to a defense. Okay, to see what they know and what they don't know. So you have that audit trail. For any deans that are on the phone on this call, this is also great for accreditors to really show um, what um, what students know and leave that audit trail. This is something that AI will never have, which is purpose-built audit trails to see where students are and to show accreditors. Okay. So I think with that, I will just open up to calls or go to projects and see what's here. One of the nice things about Intellectus Statistics is that you can share projects, as Elizabeth has done twice. Okay. So why don't we get Elizabeth? Please use the more recent one. Okay. So
Yes, I changed the data set, and when I uploaded the new one, it created a new project.
no problem.
So I have attempted to use this a few times and I keep getting stuck. My main question is to look for correlations between job family in column A and all
So
40
okay,
items in
wait. So
columns
job, family,
D through
column A.
AQ.
Okay, hang on here.
Mm-hmm.
Hang on. All right. So correlation between job, family. Let's just take one of them. Okay,
Mm-hmm.
job, family, and one other variable, for example.
Anything from D to the end.
Okay.
But what
So
you're saying is already one of the things I'm running into. I haven't even been able to run descriptives on more than 10 items at a time. Is there any way around that to look at the whole set of 40 items together?
unfortunately, when it comes to ordinal variables, okay, tables don't look good if it's 10 pages long. If they were all scale, okay, then it
Mm-hmm.
would be, okay.
Okay.
Uh, now, are these things like present or absent or yes, no? What are these things?
They were originally a 4 item scale
Okay,
from not at all to there were some
okay,
things, but they weren't really scale. So I turned them into either not at all or yes, basically
okay.
0 and 1.
Not at all or yes. Well, I would have yes, no, or so something like that, but I'll go with what you're saying here. So
Sure.
one,
0 or 1.
well, I want to name them something because they
Okay, so no change and change would
fine.
be,
Okay. So terrific. So let me show you a couple things. So one is when we can edit variables at the same, recode multiple variables. So I can recode, let's just say, population health, nominal. Okay, this is all being recorded. So I can click on all of these, okay? Let's
Mhm.
just call them nominal, okay? All right. And this is no change, okay?
Mhm.
And then change. Okay. So, one, you can, I would keep labels labeled, okay? Um, I know SPSS has got that funky thing of, um, you know, 0 is female, 1 is male, or whatever.
Yes.
Just keep the labels in here, okay? That's one piece of it. The other one is you want to make sure that this is all cool. So, okay, oh boy. So you got a lot going on here with job family, right? So,
Mhm.
I mean, look, I mean, out of 922, these three, I'm either going to bucket into somewhere else. This is more consulting kind of stuff, but for the moment, let's just say I would get rid of these guys. Okay. All
Yeah,
right.
those actually should have been in some of the others.
Okay. So let me delete these. Yeah.
Sure.
Okay. Okay. So you want to look at your variables, and you would have picked it up in descriptive. So, and we can do that real quick. So under descriptives, I'm just going to deal with these first few variables. Okay, job, family, and then I think we're here. Okay, so definitely everyone you want to do descriptives. Well, you want to run descriptives and then you want to read what you did. Okay, I've conducted them and then not read them and then paid the price. So you would have picked up those people that have won. Okay, all right.
Mhm.
So and then you can see that over here, and then factor decision where that's truly ratio is fine. So that looks fine. Now you said I want to correlate these things.
Mhm.
Really, I think the better way to say that is I want to look at the relationship between them because correlations really look at either scale and scale. Okay. Okay. Let's just do this
Okay.
thing. So
So the
relationships,
actual research question,
yeah.
are there differences in elements that promote engagement across different professions? So basically, does the profession change which of those elements they participated in?
So for example, and this is one like population community event, right?
Hmm.
Okay. So you want to wait. So two things I would do here. One is I would see if there's any darn relationship going on here. Okay. I mean, I'm not crazy about these guys. This 2%. I
Hmm.
mean, really, what I really care about is probably those first guys. But
Yes.
for the moment, let's keep them in there. So I would do two things. So one is I'm going to run a quick chi-square, okay, just to see if there's any relationship between my job, okay, and okay, and my first one of these things, population event. Is there any
Does that
relation?
have to be done individually for each item?
I don't think you can. Yes,
Okay.
yeah. Which has a disadvantage, by the way. Sorry to say it, but I mean, if you're using job, family, and all these things, well, I'll show you in a second. This isn't the real test at hand either, by the way. So, so there's no relationship going on here between family and okay, change or no change in this event. I think what you really want to be doing is conducting a series of binary. Well, two things here. One is probably a binary logistic regression at the individual level. My outcome variable is the event, and my predictor is my job family. Um, I think really what you want to be running. This model is not significant, okay, with regard to this. You probably want to run a path model. Um, uh, two scale variables. Hmm, I would not keep them scale. We have to think about that, okay? But you probably want to run some model where you have all these outcomes at the same time, okay?
Hmm.
That's probably where you want to go. And I probably would mess with your data a little bit, where they're not even ordinal. Maybe I keep them as scale, okay? Um, so that when you're looking at all those things simultaneously and you have a beautiful data set size, that's what you
Hmm.
might want to be doing. Okay.
Okay.
Um, but I would be running the univariate. I mean, your question is taken well, which is, can I run all these things at the same time? No, but it does. But I mean, let's be fair to the tool. It takes, well, let's just count. Melissa, you can count, okay? So if I did a chi-square well, here's what I would do. Once I ran one chi-square, I would go to edit, new analysis, change it to the next one. I think that's 10 seconds. So how many variables do you have?
40.
It's a fair amount. 40 times is it 10 times 10 seconds. So that's 400. So it's going to take you 3 minutes. You know.
Okay.
All right. So I think I would think I would be running those things separately. Okay. Is
Mhm.
there any relationship going on at all? Okay. I'd probably consider getting rid of some of these um those smaller frequency ones.
Mhm.
Okay. Um yeah, those 2%. All right. Other questions you had around your data set?
Nope, that was it. Thank you.
Yeah, no, that's fine. Thanks for checking us out and try it for sure, you know, look at that discussion. And the main questions are what was the impact of this job family on these other outcomes? Correct?
Yeah, that was the main thing I was hoping to do in Intellectus specifically.
Yeah, I think I would just run a bunch of chi-squares. See if there's any relationship at all before you start getting into more complicated binary logistic regressions or a path model.
Thank you.
Is there anything going on between these guys, job family and these other ones, and take it from there?
Mhm.
Yeah. All right. Hey, I wish you well.
Thank you.
Yeah, have a good weekend. All right.
But
Bye for now. All right. Hi. Okay. So, any other data sets or questions going on here, Ms. Moran?
I don't have any right this second,
That's
but if you
fine.
have questions about your project, feel free to raise your hand, and we can unmute you or put them in the chat or the Q&A.
Also, while I'm here, we have a breather. Um, okay, and let me see if I can just grab this quick slide here. Um, so, um, so how confident do you feel about running your own analysis yourself? Ready to run it myself, getting there, still have questions. And if you put those into the chat, we have the poll up. Great. Let me see if basically did I do my job? Okay. Uh, Getting there. Okay. 1 second here. Hang on. Okay. And about 8 out of 10 are getting there. Good. Still have questions. All right. Come back. I'm ready to run it by myself. 10%. Okay. It's terrific. Let me just also put out a QR code. If you'd like a complimentary 20% consult with me or needs assessment, feel free to take a picture of that. You can also reach Samantha for student support. If Ashley's here to help with trials and demos for faculty, Melissa for all other questions. Our phone number, we have two websites. One is with the kind of Intellectus tools, and the other one is more kind of quant statistic solutions. Okay. Um, okay. Any other questions to be had here, Ms. Moran?
We have one more person that may have shared their data with you.
Okay.
I'm gonna
Okay.
unmute.
Yep. Okay. So let me refresh this. Okay. So if I refresh this,
Chloe, did you share your data set?
I don't think so.
And you're unmuted, so you can.
Hmm. Okay. I don't see you here. Hi, Chloe. I have your hand up, but I think you're unmuted.
All right.
Chloe,
We may have to wait on Chloe.
no worries.
No, we cannot hear you.
And any other,
Well, and while Chloe's working that out, we did have a few questions come in about what's AI, what's not AI. So just a quick
okay,
clarification on
great.
what is and isn't.
So certainly any of the data management is not AI. Certainly any of the plots is not AI. Certainly the analyses are not AI. The decision tree is not AI, although I think it should be. The power analysis and data plans are not AI. Okay, so those are all hard coded, and the results, if I can get there, and the if I get there. Oh, let me go back. And the results are all hard coded. AP tables hard coded. The AI is in the discussion draft. Oops, I didn't want to just generate one. I wanted to just show one. The discussion draft that I showed you earlier, that is AI driven. So that is something that you want to obviously vet line by line. Okay. And then the guided reflections are not AI driven. Those are hard coded questions to make sure or to ensure that you understand those that discussion. Okay.
And then one more thing, because someone had a question, I think it was good. The references that
Hmm.
come with the results are
So
100% as well.
correct. I mean to AI, yes. So do I have output here? Um, I don't have results. I think it's this first one for some reason. So these results, when you download that, so these are the results of my analyses. Make this bigger. Okay. And there are APA references for all the in-text citations. Those are not AI driven. The discussion chapter, those are AI driven. But the truth is, they're getting better and better every day. I would still double check those, okay, that whole thing, but they've gotten much better, okay,
And then
and double check.
we have two questions in the Q&A.
Okay, I have different data subset. I have a different data subset on my Microsoft Excel. Do I upload them one after another or to run analysis? So no. So if you have subsets, you want them all on the same sheet. Even though you may have different, number in that cohort, okay, or in that group. So um, so you want, let's just say this was one subset, okay? And then the other subset, you only have, okay, these are different variables, okay? Maybe just group, okay, whatever. Okay, so these could be different variables. So you want this subset and this subset, okay, in the same data set. Because you'll want those results downloaded together. You want the discussion downloaded together. So you want to put it in one analysis. Phyllis asked, I'm developing a 38-item attitude scale that will be administered to the same participants before and after a 15-week education. Would a paired sample t-test be the most appropriate to determine the overall change? So I have a couple comments here. So one comment is, so yes, if I have a total score of attitudes pre to post, or even a subscale of attitude pre to post, paired t-test is the test. Not crazy about making your own scale. Most people want to most people, I'm going to say, would want to see, did my intervention change attitudes? Okay. Most people in your situation are probably not saying, let me develop an attitude scale, let me then validate the scale and so forth. When you develop your own attitude scale, you have to assess validity. You can assess reliability pretty quickly, but you want to assess validity, okay? And if you have not run it, my suggestion to you is take an existing attitude scale with the reliability and validity associated with it, okay, and then adapt it, okay? That would be one thing to consider, okay? Okay. Also involve subscales separately. No, so Phyllis's question is, hey gosh, if I have several subscales of attitude one, attitude two, pre to post, you probably just want to run a MANOVA, a repeated measures MANOVA. Let me just demonstrate that real quick. So let's just say I have this. So if I attitude one pre, attitude two pre, and then attitude one post, and you could have as many attitudes as you want. Well, I think we carry up to five. I think eight attitude two posts. You get the idea. Okay, let's just mess up some of the numbers here. Actually, make these. Oopsie. Just trying to get something going here. Okay, so you would have, so there's a couple of things here happening here. One thing that's happening is all of your attitude measures are in columns. All of your participants have a score on each of these attitudes. Okay. And the test at hand would happen to be a MANOVA, repeated measures MANOVA, where I'm assessing, I have two DVs measured at 2 time points. Okay. And attitude pre at time 1, attitude 1 at post. Okay. Attitude 2 at pre, attitude 2 at post. Okay. And by the way, if you change those DVs, you would get yet another level, okay? And time points. So you can have number of DVs sitting here and the number of time points, but I think we have up to 5. Okay. So all right. So let's just for the demonstration purposes. Mess myself up here. Do one post. Two pre. So this is how you would run it. Okay. And the variables. Okay. And the question at hand here is there a simultaneous difference on both of these attitudes pre to post? So there's assumptions you can look at. By the way, helpful scroll overs to see if it looks more normal or not. This is the overall, you can see, is there overall difference from pre to post? Yes, there is. Is there an interaction between time and factors? No. This is going to be helpful. So anyway, so this is the procedure. You can kind of see what's happening. This is pre to post. These are my DVs. Okay. And you kind of see, hey, gosh, there's an overall difference from pre to post. And then so that's how you would do it simultaneously, okay? And you would look at those. Okay. So instead of doing them individually, I think I would run that repeated measures maneuver. Okay. All right. Okay, final questions, final thoughts? Okay. So I want to thank everyone for attending. We will be doing a data analysis plan workshop, a DMP workshop coming up, a qualitative workshop coming up. Once we have the methods app up and running, we will have a workshop on that as well. Again, faculty, students, feel free to contact Ashley or Samantha, and they'll be able to kind of triage you appropriately. And thanks a lot. And please do share these with other folks. People don't know that there's free webinars happening. I hope you found some value in it, and just wish everyone a wonderful weekend. So with that, I'll say so long and stay safe.